What Voyager detected at the edge of the solar system. For most spacecraft, the story ends long before the edge of the solar system. They orbit planets, study moons, burn through their fuel, and eventually fall silent. But Voyager was different. Launched in 1977, it was built for a mission that already sounded impossible. Fly past the giant planets, use their gravity like stepping stones, and keep going until the sun itself began to fade behind it. Decades later, long after its original mission should have become history, Voyager was still alive. It had passed Jupiter. It had passed Saturn. Its twin had visited Uranus and Neptune. And then, instead of stopping, these tiny machines continued outward, moving farther from Earth than anything humanity had ever built. At the edge of the sun's influence, Voyager did not find a clean border or a glowing wall. It found something stranger, a restless boundary where particles, magnetic fields, and invisible waves collide. It detected changes that showed our solar system is not simply floating quietly in space. It is pushing against something, and something is pushing back. The mission that was supposed to end. When Voyager 1 and Voyager 2 left Earth, no one expected them to become humanity's first messengers to interstellar space. Their main job was to visit the outer planets. Voyager 1 flew by Jupiter and Saturn, sending back images that changed how we saw the gas giants and their moons. Voyager 2 took the longer path, visiting Jupiter, Saturn, Uranus, and Neptune. After those flybys, the spacecraft should have been remembered as one of NASA's greatest planetary missions. But the Voyagers kept working. Their cameras were eventually turned off, their power slowly declined, and one by one, instruments had to be shut down to save energy. Still, they kept sending signals home. Those signals are weak now. By the time they reach Earth, they are faint whispers from billions of miles away. But inside those whispers is something no telescope from Earth could give us. Voyager is not just looking at the edge of the solar system, it is touching it. The edge is not a wall. When people hear the edge of our solar system, it's easy to imagine a line in space, as if Voyager crossed a border and suddenly left one kingdom for another. But the real edge is much more complicated. The sun is constantly releasing a stream of charged particles called the solar wind. This wind blows outward in every direction, creating a huge bubble around the planets. That bubble is called the heliosphere. Inside it, the sun's influence dominates. Outside it, the environment belongs more to interstellar space, the thin material between the stars. The boundary between these two regions is called the heliopause. It is not solid. It is not visible. It does not look like a wall. It is a shifting, uneven frontier where the solar wind slows down and presses against the interstellar medium. And this is where Voyager began to detect that space around it was changing, the first signs of something different. As Voyager moved downward, scientists watched for signs that it was approaching the heliopause. They expected particle levels to change. They expected cosmic rays from outside the solar system to increase. They expected particles from the sun to fade. That is exactly what began to happen. The particles coming from the sun dropped sharply, while high-energy cosmic rays from interstellar space increased. It was as if Voyager had moved from inside the sun's protective bubble into a darker, more exposed ocean beyond it. But the data was not as simple as scientists expected. The magnetic field did not suddenly shift in a way many thought it would. Instead, it stayed strangely aligned, making the crossing more confusing. For a while, researchers debated whether Voyager had truly left the heliosphere or entered some strange final layer near the edge. Then the plasma waves helped answer that question. The sound of interstellar space. Voyager 1's plasma wave instrument detected vibrations in the thin gas around it. These were not sounds in the normal sense, because space does not carry sound the way air does on Earth. But when the plasma waves were translated into frequencies humans can hear, they became eerie tones rising through the darkness. Those tones told scientists something important. The density of plasma around Voyager was much higher than it would be expected inside the heliosphere. That meant Voyager had entered a new environment. It had crossed into interstellar space. This was one of the most important discoveries in the entire mission. Humanity had not just looked at interstellar space from far away. For the first time, a human-made object was measuring it directly. And it was not empty. The persistent hum. Later, Voyager 1 detected something even more haunting, a faint, persistent hum of plasma waves in interstellar space. It was not a dramatic burst or a single strange event. It was more like a quiet background vibration, a steady signal from the thin material between the stars. That discovery changed the way scientists thought about the emptiness beyond the solar system. Interstellar space is often imagined as a silent void, but Voyager showed that even out there is structure, motion, and activity. The space between stars has its own weather, its own turbulence, and its own invisible rhythm. The hum was weak, but that is exactly what made it powerful. It suggested that Voyager could keep measuring the density of interstellar plasma even without major solar eruptions passing by. In other words, the spacecraft could still map the environment beyond the sun while drifting through a place no machine had ever explored before. What Voyager revealed about our solar system. What Voyager found at the edge of the solar system was not one single answer. It was a completely new picture of where we live. The solar system is not just a collection of planets orbiting the sun. It is surrounded by a protective bubble carved out by the solar wind. That bubble shields us from some cosmic radiation, but it's not perfect. It bends, shifts, and reacts to interstellar medium outside it. Voyager showed that the boundary is messy and alive with invisible forces. It's a place where solar particles fade, cosmic rays rise, plasma density changes, and magnetic fields behave in ways that still raise questions. This matters because the heliosphere protects every planet inside it, including Earth. Understanding its edge helps scientists understand how stars interact with the galaxy around them and how our own star shields us from the harsher environment beyond. The slow goodbye. The most emotional part of the Voyager story is that even now the spacecraft are slowly fading. Their power comes from radioactive material that produces less energy each year. To keep the mission alive, engineers have had to shut down instruments one by one. Every decision is difficult. Turning off an instrument means losing a way of sensing the universe, but keeping the spacecraft alive means preserving the chance to receive a few more messages from a place we cannot reach. Voyager is now old, fragile, and impossibly far away. Commands from Earth take many hours to arrive, and the answers take many hours to come back. It is less like operating a machine and more like caring for a faint voice at the edge of darkness. So what did Voyager detect at the edge of the solar system? It detected that the edge is not empty. It found a boundary shaped by pressure, particles, plasma waves, magnetic fields, and cosmic radiation. It found that the sun's influence does not simply end. It fades into a strange and active frontier. Most importantly, Voyager showed us that interstellar space is not just a silent void waiting beyond the planets. It has texture. It has density. It has a faint hum. And that may be the most haunting discovery of all. After traveling for decades, after leaving the planets behind, after crossing beyond the bubble of the sun, Voyager did not enter nothingness. It entered another environment, one we are only beginning to understand. One day the final signal from Voyager will reach Earth, and then the spacecraft will go silent forever. But even after that, it will keep drifting through the dark, carrying the story of Earth on a golden record, moving deeper into the space between stars. And somewhere, far beyond the reach of its radio signal, the little spacecraft that once touched the edge of the solar system will continue into the unknown.